With disturbing regularity, websites are hacked and millions of passwords are leaked online. And one thing we're constantly reminded of is that people are terrible at choosing passwords. In this Python project, we'll use the GooeyPie library to create this app that generates a good password. This tutorial will be broken down into the following sections. We'll start by designing the user interface, writing the code to produce the password, writing code to create the user interface, and then bringing it all together. All of this will result in about 100 lines of code, so let's get started. On the GooeyPie website, you'll find this PowerPoint template, giving you a nice, easy way to plan the layout and visualize the final product. Our password generator will allow the user to select a password length with the slider and 3 checkboxes to set the options for the password. The generated password will populate an input box which is editable. The user can generate a new password with the same settings by pressing the reload button, and it can be copied to the operating system's clipboard. Over in Visual Studio Code, I'll create a new Python file and call it app.py. From my design, you can see that the password generation function needs a length and a set of options for the generated password: letters, digits, and symbols. So, how do we make a password? One approach is to create a set of possible characters, then randomly choose one at a time until we have a string of the required length, and that's the approach we'll take here. For these characters, I'll use some constants from the Python string library. We can see what these are by opening a Python session in the integrated terminal of VS Code. After I import the string library, string.ASCII letters gives us 52 uppercase and lowercase letters, string.digits for our numbers, and we'll use string.punctuation for the symbols. Back in the Python app, I'll first import the string library at the top of my file. Then inside the function, I'll start by defining a variable called available_chars, set initially to the empty string. Then it's a matter of adding to the string all possible characters that could be in the password, depending on the letters, digits, and symbols parameters. If the user wants letters, then I'll add all the letters to the available_chars variable, and I'll do the same thing with the digits and the symbols. To then create a new password, I'll first import the choice method from Python's random library. This will allow me to choose a single character from a string. I'll then create a variable for the new password, initialized to the empty string. I need to choose one random character at a time to append to this variable, and I need to do it length times, where length is the first argument to the function. So I'll use a for loop with the range function to loop the required number of times, and on each run of the loop, I'll append a random character chosen from the available characters set above. And now I've got my password, I'll return it as the last step. Now I can run a few simple tests to see how this function is working by using the same Python interactive session I was using before. Since the file is called app.py, I can import the function from app, and then I can call the function directly inside this session. As I call the function with 10 for the length and true for all options, you can see that it's returning a different password consisting of letters, digits, and symbols each time. And here you can see that I'm just experimenting with different options, and it seems to be working as expected. One important point here though is that if all 3 password options are false, an exception will be raised by the call to choice, since it's trying to choose a character from an empty string. We'll deal with that problem in the GUI code. Time to code our interface now. I've saved out my design as an image to the project directory, and if I open that in a new tab and move it over to the side, that will be a useful reference as I write my code. I've also given myself a bit more room by closing the Explorer panel. I've already installed the GooeyPie library, so I'll import that as GP, which allows me to use that shorter GP prefix. I'll create the main application object and window with a call to GooeyPie app, passing in the title of the window. I'm also going to prevent the window from being resized vertically by setting the app's resizable vertical property to false. Another thing I'll do is set up a variable to set the default password length. I'll make it 8 characters. So our design requires 3 label containers. These widgets have a light border and some text to help separate out logical areas of our app. I need one for the password length, one for the password options, and the last one for the password itself. Each of these containers belong to the main window, so I need to specify that app variable as the first argument, and the text that appears on the label container as the second. These widgets need to be created first in my code, as the first argument when creating any widget is the window or container to which it will be added. Now that my label containers are set up, I can start creating all widgets, beginning with the label and slider associated with the length container. The label will initially show the default password length, so I'll use that variable defined above in an f-string to set that value. The slider limits will determine the minimum and maximum possible generated password length, and I'm going to choose 4 and 50 for those values. The 3 checkboxes for setting up the password options, letters, digits, and symbols, all belong to the options container, and I'll set the checked property of each checkbox to true. The remaining widgets will be added into the password container, starting with an input used to display the password. Being an input widget, this will allow the user to edit the generated password if they wish to, and I'll set the width of the input to 40 characters, which will accommodate most generated passwords. The reload button is an image button. I found a suitable icon from iconsdb.com and saved it to the project directory. I need to specify the file name of the image and the name of the function to call when that button is pressed. Now, as we'll see, it's important to note that we can't actually directly call the generate password function we've already written as the event function. So for now, I'll just use none. The final widget is the copy to clipboard button, and this too will just have none as its event function until we write it later. We now have all of our containers and widgets created, so it's time to add them all to the window. All widgets are added to a grid in GooeyPie, and all containers have their own grid. Before we can add any widgets, we need to define the grid of the container or window. So starting with the length container, its grid is 2 rows and 1 column, and then we can call the add method of the container to add the length label to row 1 column 1 and the slider to row 2 column 1. The options container is 3 rows and 1 column, so I'll define that grid and then add each checkbox. And lastly, the password container is 2 rows and 2 columns, with the password input sitting in row 1 column 1, the reload button in row 1 column 2, and the copy to clipboard button in row 2 column 1. It's almost time to see what our app looks like, but even though we've added all of our widgets to their containers, we still need to add the containers themselves to the main window. To accommodate those containers, I need to set the grid on the main window to 3 rows and 1 column, then add each container to the relevant row and column. Our last line is app.run, which will launch the window, and when we save and run the code, we can see that all of the widgets are in their correct places, but the layout leaves a bit to be desired. So let's fix that by setting some layout options. The containers are not the same width, because by default each one will only be as wide as it needs to be to accommodate the widgets they contain. By setting the layout property fill equals true, then each container will be as wide as it can be within its grid space. Saving and running the code now, we can see that the containers are all the same width. The length slider has a default width that is less than what's available, so I'll go up to where we added the slider to its container and set fill equals true there as well, so that it fills the space available. Looking toward the bottom now, we can see that the reload button is taller than the input, and it's going to look a bit nicer if they were the same height. So where I added the input, I'll set stretch equals true, which will give the input the instruction to stretch vertically within its row. And now that will be the same height as the reload button. Let's see what happens when we resize the window horizontally. The label containers and the slider are using up all their horizontal space, which is good, but the password and the reload button are just drifting away from each other. This is normal default behavior. In this case, we haven't said anything about how the widgets should take up any extra space relative to one another. So that extra space is being equally distributed between the 2 columns of the password container grid. Neither widget is being told to fill horizontally either, which results in all that extra space. The first step is to specify the column weights for the password container. I need to pass 2 numbers to the setColumnWeight methods, corresponding to the 2 columns in the password container grid. A non-zero value tells a column to grow, while a value of 0 tells that column to only take up as much space as its widest widget. We want the first column to grow and the second one not to, so I'll pass in 1 and 0. Now, while this will allocate any extra space to the password input, I still need to tell the input to take up that available space, and I'll do that just like we've done a few times already by setting the fill option to true when we added the input. Running the code now, we can see that as I resize the window horizontally, the password input takes up as much space as it can. It's time now to connect our GUI with the generate password function to make it all work. We need to write an event function whose main job will be to call the generate password function with the appropriate arguments and use the return value to populate the password input. I'll call this function showNewPassword. All event functions in GooeyPie are passed an event object, so even though we won't be using this object, we still need to include the parameter when we write our function. Let's dive right in. I'll simply set the contents of the password input using its text property to the return value of calling the generate password function. As we know, we need to pass in 4 arguments to the generate password function, the length of the password, and 3 Boolean values for the options. All of these values are properties of the relevant widgets in our app. The length is the value property of the slider, and the 3 options are the checked property of the corresponding checkboxes. I now need to associate that event function with the reload button, so back where I created the button, I'll replace the none used earlier with the name of the event function. I'm also going to set the length of the slider to its default value using the default password length variable I defined earlier. Running the code now, whenever I press that reload button, a new password is created and displayed with the specified length and options. However, we do run into that problem where if none of the checkboxes are selected, we get an error. So I'll go back up to the event function and check that at least one of those options is selected. There's a few ways to check for this, but here I'm going to be really verbose and in an if statement, test if the checked property of all 3 checkboxes is false. If that's the case, I can pop up an alert window that lets the user know what the problem is and what action they need to take, and I'll classify this alert as an error message. I'll move the rest of the code into the else part of that if statement so that it only runs if one of the options are chosen. Let's test this now. Creating some passwords, changing the length, changing the options. But then if no options are chosen, there's our error message. You might have noticed just then that the label that accompanies our slider never changes no matter what the value of the slider. So in the function, we'll update that label to the value of the slider by setting its text using the slider's value in an F string. So whenever the password changes, the label will change to reflect the number of characters in the password. The label now updates, but only when we press the reload button. To make the label change with the slider and not just when the button is pressed, we'll add an event listener to the slider, listening for the change event and calling our event function when it's detected. So now when the slider moves, the label updates and a new password is generated. We can make this app even more responsive by regenerating a password every time one of the checkboxes is checked or unchecked, so that the password displayed always matches both the length and the options specified. We'll add change event listeners to each checkbox, calling the showNewPassword function whenever that change is detected. So now a new password is generated and displayed when the slider moves or any of the checkboxes change. The only thing left to do now is to make this copy to clipboard button work. So we'll need to write a new event function with that event parameter. And it's just a matter of calling the copy to clipboard method on the app object, passing in the current contents of the password input by referring to its text property. Don't forget to replace the none we used when we created the button with that function name. So that's it, a customizable password generator capable of making passwords that should pass even the most stringent of requirements. If you want to learn more about GooeyPie, check out the resources and examples on GooeyPie.dev, and I'll see you in the next one.